Very privileged to have with us Dr. Lerwen Liu, who is going to speak to us about emerging nanotechnology power. The CV is up there on the screen.
This seminar is going to be two parts. The first part is with the rest of the audience as well, so it will be an interactive seminar, the first part. Second part will be more on the content of the book, but instead of talking about the book, I will tell you stories, why I wrote this book, and my traveling and my visits in the last 10 years across Asia Pacific, and understanding the nanotechnology initiatives, how the initiatives in every... What is nano, right? Nano in terms of scale. Now you see this interesting movie going on there. It's actually a growth of nanotube made by Dr. Lerwen Liu's group in Imri, just a 5-minute walk from me. So nanoscale is 1 billionth of a meter, so 10 to the minus 9. So how do you imagine this scale? So let's start from a millimeter scale. So you see an ant. Ant is the size of a millimeter. So if you go down to another level of scale, say bacteria, which you can see probably under the optical microscope, is the order of 100 micron. So micron is 10 to the minus 6 meter. And then you can see blood cells, also size of order of a micron. And a hair, human hair, is the order of 100 micron. And if you keep zooming down, you see DNA. The width of a DNA is the size of a nanometer. And of course, size of atom is 0.1 of a nanometer. My favorite example of nanotechnologies is the lotus effect. If you look at the cover of the book, it is lotus effect. The leaves is not lotus, it's rice leaves, but the same structure. And basically, you look at the lotus under the scanning electron microscope. You see all the bumps. Okay, so the bumps is able to hold a water droplet, and so the fact that the water droplet doesn't wet your surface, or any other material wet your monosource wet your surface to your shirt, is that it's a combination of the effect of the length scale roughness. If I want to explain it more technically, is the contact angle of the droplet is larger than the critical angle when the droplet gets flat.
Where is the focal point? Is it A star?
I think as far as nanotechnology capabilities go, A-STAR really is the driving institute for a lot of the nanotechnology work that's being done. Yeah. Of course, there's a lot of good work being done in NUS and NTU as well. Let's not forget that. Thanks.
And now I'll speak.
Yeah, Michael.
I think Justin made a very, I'm Michael Kwa, and I'm temporarily with NUS at least for another 2 weeks at the Energy Studies Institute. The question that Justin made was a very good one. Nanotechnology, as Lerwen shows, pervades a lot of our industry. You know, when I was younger, and I'm really an old man right now, we didn't used to use the buzzword nano. We did submicron particles. And let me explain to you, that's why the whole area that it is a technology that pervades a lot of other technologies and provides a building block into others. And therefore, if you distinguish itself, you don't connect it to its supply chain. Let me give you an example, because I spent most of my career in industry in DuPont. And many people who work in the energy industry understand the Nafion membrane. Now, DuPont wasn't buzzwordy enough to understand that really the functional expertise of that membrane is that it has nanochannels. But we did not know Wall Street buzzword. We called it submicron channel. But these are very equivalent to the Gramocidin channels that allow the passage of cations through the polymer membrane. So that's why Nafion is used in fuel cells, but actually more extensively in the chlor-alkali industry, where you have cationic transport. And I'm
to share with you the Asian nanotechnology development, primarily on the policy side, policy and strategy side. So those of you who are government policymakers, social scientists, will find it more interesting. I started monitoring Asian nanotechnology development since 1999 when I was a technology analyst in Tokyo, working for an American think tank. And of course, the country to focus on at that time was Japan. I mean, Japan started its major nanotech program in 1992. And before that, there are already, in the 80s, they started already very large programs in nanoscience and nanoparticles. Actually, one of their first nanotech program was nanoparticle synthesis. But that was launched in the 80s. And the key player at that time was led by UVEC, the company UVEC. I don't really know, high vacuum systems. And then after Clinton announced the initiative, all the other, the whole world kind of started to look at nano, and as Michael mentioned, and then it became so-called the Wall Street keyword, nano, and a lot of investors pouring money into nanotech startups. Because, basically when government spends so much money, the private side like to also to see the opportunity, and they like to take share the risks, share the opportunity as well. So the region I cover are in pink: Japan, China, India, so the North Asia, South Korea, all the way down to Australia and New Zealand. So this is the 13 economies, the 14 founding economies under the so-called Asia Nano Forum. I'm a co-founder of the Asia Nano Forum. Its secretariat office is actually located in. Let's not forget the two largest, the most populated country, China and India. Maybe I'll spend a little bit of time on that. China, you all know China is, if you look at the science citation in nanoscience, China is ranked number 3 or 4. I don't know, it's in the book somewhere. I don't remember. So China has been really well known for its nanoscience research. But for commercialization, you probably can anticipate China doesn't have the industry infrastructure as in Japan, Korea, or Taiwan. So there's a big gap between their research and commercialization. Not sure what to do about that, but I think the encouraging sign for China to be a commercialization leader in nanotechnology is to oversee Chinese returning to China to lead significant research programs and running startups. I just came back from Shanghai. So now, if I just for the sort of sake of curiosity, you want to compare, typically we compare the 3 largest economies, although now China has taken over Germany, but in the old days. Germany, Japan, USA. Right? In terms of per capita spending, Japan per capita has the highest spending in nanotechnology, while overall the total spending in the US is always the top.